As part of my problem series in this video, I'll be analyzing the two-loop circuit with multiple resistors and two power supplies, this time using nodal analysis. Once I'm finished with this series of problems, I'll be posting them on my StanStore at this web address. Before proceeding, I want to explain the three web addresses that you will be directed to using. You have already seen the first here. This is a web address of my StanStore, which will give you direct access to all of my electrical courses. On the last page, you'll find an address that will direct you to obtaining the 50-page crib sheet and notes that will not only be handy when you're taking my courses in my StanStore, but also for reference during any time during your career. Here you'll also be asked for your email address, which will not be shared with anybody or distributed in any way, but it will allow me to keep in touch with you and let you know of any additions or updates to my courses and or blogs. Near the end of the video, I'll be introducing you to a supplier of electrical products, which in my estimation are of value worth paying attention to. In this problem, we are going to calculate the current through each of the resistors in this DC circuit using nodal analysis or branch current method of solution. I'm going to redraw the circuit now slightly just to make the nodes more obvious. Step 1. Label the circuit elements, all nodes. One of the nodes, node A, is chosen as the reference node. It can be thought of as circuit ground, which is at 0 voltage or ground potential. Node B and node D are already known to be at the potential of the source voltage. The voltage at node C, the voltage we call VC, is unknown. Let's assume that VC is greater than the voltage at node B and is greater than the voltage at node D. When all three currents are drawn arbitrarily, remember these directions are arbitrary and may change depending on the outcome of the mathematics. The direction of I1, I2, and I3 is assumed to be emanating from node C and towards the reference node A. Step 2. Write Kirchhoff's current law at node C, which gives us this equation. I1 plus I2 plus I3 equals 0. Step number 3. Express the currents in terms of circuit voltages using Ohm's law. I1 is equal to V1 all over R1, which is equal to VC minus 8 all over 2. I2 is equal to V2 divided by R2, which is equal to the quantity VC minus 24 all over 1. And I3 is equal to V3 divided by R3, which is equal to VC divided by 4. Substituting the current equations obtained in step 3 into Kirchhoff's current law of step 2, we find I1 plus I2 plus I3 equals 0 becomes the quantity VC minus 8 all over 2 plus the quantity VC minus 24 all over 1 plus VC over 4 is equal to 0. Removing the denominators by multiplying the equation by 4 gives us this equation. Removing the brackets, bringing all of the unknowns to the left-hand side of the equation, gives us this, which reduces to this, and this simple equation can be solved to obtain VC, which is equal to 16 volts. Solving for the current is very simple. All we have to do is substitute 16 for the voltage VC. In our equation for I1, we get 4 amps, and our equation for I2, we get minus 8 amps, and our equation for I3, we get 4 amps. And not surprisingly, we get the same answers that we have previously found for the currents. Notice that I2, we obtain an answer of minus 8 amps, which means we assumed the wrong direction in the beginning, and this means that the current is actually 8 amps flowing in the other direction. I want to introduce you to another product that's out there that is worthy of paying attention to, the 𝐃𝐈𝐒𝐂𝐋 F2000 generator. To find out more about this battery generator and to keep up to date on any sales or discounts that are available, simply go to the Anchor site at this web address. And by using this web address, you can get $800 off the original price, or just browse through the various options on this site. There is no charge for just looking, but you might find something that is available at a discounted price at this particular time. And remember, this video has been brought to you by PSPT, where you will find electrical training videos when you go to this web address, which will also give you a free copy of my 50-page crib sheets that you can use while viewing any of my courses, or just keep it handy during your everyday work.